This is sample problem 3.2. It says in this problem that lithium carbonate, which has the chemical formula Li2CO3, was the first mood-stabilizing drug approved by the FDA, that's the Federal Drug Administration, for the treatment of mania and manic depressive illness, also known as bipolar disorder. Calculate the percent composition by mass of lithium carbonate. So let's take a look at this one right here. Okay, we're doing percent composition. In your textbook, they give you a formula for percent composition. Essentially, what we want to do is we want to find out what percentage each element is of the total. So we want to calculate percent lithium, percent carbon, and percent oxygen. Those are the three elements in the compound, right? Li2CO3. So here's how you go about it. It's a very simple calculation. Some of these calculations are really simple. This is one of them. It's fun to do. Here's what you do. You essentially write out how much each element weighs and then divide that by the either molecular mass or formula mass. In this case, lithium carbonate is an ionic compound because it has a metal lithium, so that would be a formula mass. So how many lithiums are in the formula? Here's what you do. You look at the formula, Li2. That tells us there's 2 lithiums. So you write 2, and then you look up the atomic mass of lithium, 6.94 AMU. And then you divide that by the formula mass. Now, how do we calculate the formula mass? I'm going to do that down here. We did that in the previous problem. 2 times 6.94, 2 lithiums, plus 1 times 12.01, 1 carbon, plus 3 times 16. .00. Okay? And then let's pull out the calculator and add that all up. 2 times 6.94 plus 12.01 plus 3 times 16.00, and you get 73.89. All right? So now you divide the lithium by this formula mass. And this would be called the mass fraction of lithium, but we want mass percent. If you recall, if you want to convert a fraction to a percent, you multiply by 100%, right? So now we have 2 times 6.94. And we're going to divide that by 73.89, and then we're going to multiply by 100. And that comes out to 18.78. Let me see if there's any more digits that come after that. 7847. But now let's do our rounding. In the numerator, the top, there's only 3 sig figs and 6.94. In the denominator, the bottom, there's 4 significant figures. 694, 3 sig figs, 7389, 4 sig figs. For multiplication division, you pick the one that has the smaller and you round to that many sig figs. So since 6.94 only has 3, we round to 3 sig figs. So 1, 2, 3. This would be the 3rd sig fig. That number that comes after it is 5 or greater. If it is 5 or greater, you round the 7 up. So if it were 18.73, you would round down and be 18.7. But since it's 18.78, the 8 is 5 or greater, you round up. So it becomes 18.8%. And there's our percent by mass lithium. That one's done. Now we do the same thing for carbon. You say, okay, the formula has 1 carbon, so 1 times 12.01. You divide that by the molecular mass, 73.89 AMU. And then you multiply that by 100%. Okay, so 12.01 divided by 73.89 times 100, and you've got 16.25%. However, let's take a look at sig figs. 1, 2, 3, 4. 1, 2, 3, 4. They both have 4, so our answer should have 4. 1, 2, 3, 1, 2, 3, 4. Looks good. There we go. 16.25. So what that's telling us is that out of this entire chemical formula, around 18.8% or around 19% of it is lithium by mass, and about 16.25% of the mass is carbon. We have one more element to do, that's oxygen. So for oxygen, there are 3 of them. So 3 times 16.00 AMU. We could divide that by the total weight, the molecular mass, or actually formula mass in this case. And then to convert it to a percentage, we would do that. So 48, 3 times 16 is 48. Divide that by 73.89. Multiply that by 100, and you get 64.96%. That's how much of the total weight or the total mass is due to oxygen. Again, 4 sig figs. The numerator, the zeros, when you have a decimal point in the number, the trailing zeros count as sig figs. So that's 4 sig figs, 1600. Each number has 4 sig figs, so we're going to round it to 64.96, which also has 4 sig figs. These 3 numbers should add up pretty close to 100. They may not come out exactly, because when you do these calculations, you round them. So sometimes the rounding will keep them from being completely 100. And notice this one, just because of the rules we're using, has 3 sig figs, not 4. Let's see how close we get to 100. 6 plus 5 is 11. 9 plus 1 is 10. Plus 8 is 18. Plus 2 is 20. 2 plus 4 is 6. Plus an 8 is 14. Plus a 6 is 20. 2 plus 6 is 8. Plus 1 is 10. So it's 100.01%. Pretty close to 100, right? It should be pretty close to 100. If you get 101% or 102% or 100, or I'm sorry, 99%, you're off by a percentage point from 100, then there might be a calculation error. But if you're within 0.01%, you're certainly, that's an issue of just the rounding. That looks pretty good. So the way we would interpret this is that most of the weight in this compound is oxygen. It's a high percentage oxygen. And lithium carbon are pretty close to each other. They're both around, 15 to 20% or so. They're pretty close to each other. So that's sample problem 3.2. As always, when you do a sample problem, do the practice problem A and the practice problem B, and that'll give you more practice doing this type of problem.